So we got interrupted by, I think her name is Miss McNeely. I only know her first name. I don't know where I was.
One radian.
Yeah, so although some students like to want to know, what's 1 degree in terms of how many radians? I find this not very useful. As a unit conversion. A lot of students want to know what 1 degree is, how many radians that is. It's not very useful. I think it's 57 point something. You can calculate it pretty well. Even 1 rad to how many degrees? Also not useful. Because 1 rad, 1 radian, notice, you'll see it hopefully in a moment what I'm trying to talk about. The most useful one is actually 180 degrees is equal to pi radians. And hopefully some of you know what I'm going to say when we talk about this in science. And we talk about what's called unit conversion. This is the best unit conversion that a lot of students will use. And how to convert from degrees into radians is exactly important. Don't get me wrong, you can definitely use the 360. The 0 and 0 doesn't help us at all. But the 90 over half pi, whatever, technically we're using this as a unit conversion. Now notice as I introduce this circle to you, it's called the unit circle for a reason because the radius is 1. So even though some of you are looking at with our special triangles, the hypotenuse was not always 1, right? It was actually, well, for the 30, 60, 90 triangle, the hypotenuse was actually 2 units. And for the 45, 45, 90 triangle, that was root 2. What are you talking about? So we can scale it and use this triangle to illustrate what we're looking at. But what I'm trying to show you right now is we're going to relate radians to the degrees, and we're going to try to change them back and forth. Okay? So let me talk about this over here. Let me just make the chalkboard, and I'll show you what I'm talking about. So let's try to convert units. So converts 150 degrees to radians. How are you going to do it? Well, it's really easy. Okay, I tend to set up a mathematical statement. So just like if you were taking science, maybe kilometers to millimeters, or meters per second to kilometers per hour, or other units, right? So some of you already know how to do this. So I like doing this with them. Question mark radians is equal to 150 degrees. We're starting with true statements. And notice we use a simple unit conversion. We're going to multiply by this ratio. This is a ratio. So notice our angle, 150 degrees, is in the numerator. This is like really 150 over 1. So I put 180 degrees in the denominator. And pi rad is in the numerator. And a lot of you already know what I'm trying to do here. Because our rational expression unit, or from our science class, you learned that the units divide out. This degree sign divides out this degree sign. And technically 150 and 180, they're reducible, right? Anyone want to tell me what number goes nicely into 150 and 180? Great? 30 degrees is correct. So this one's a nice easy one. 30 goes into 150, I think, 5 times. And 30 goes into 180 6 times. Right? So 5 times pi radians over 6. 5 pi over 6. That is an exact answer. So notice with our special triangles, you can actually convert things. And I'll try to show you a bigger understanding in a moment. Maria.
Do we always need to write rad at the end?
You don't have to, because it's actually unitless. So technically, I should not have it there. But for us being in grade 11, it's our first time kind of seeing it. I'm just emphasizing so that you guys can kind of see it as a unit, even though the definition is, it's actually unitless. Unitless. It has no units. Was there another question?
That's my question.
Yes. So that's going from degrees to radians. How about we go the other way? Converts. Let's try 5/4 pi radians to degrees. So again, again, how I like setting this one up, I put the question mark degrees on the left is equal to what it represents, 5 pi radians. So how am I going to use that unit conversion? I think you already know. We're going to multiply by, well, if the pi radians is in the numerator, then I want pi radians in the bottom and 180 degrees in the numerator. Again, I like 180 over pi or pi over 180, right? This is unit conversion. So some students might memorize it, but it's not that hard to derive, right? You can almost see it if you just do the unit circle. That's why CAST unit circle really, really helps. And again, notice in this question, the radians divide up the radians. The pi in this case actually divides up the pi's. And I think 4 goes into 180. Does it? Yeah, I think so. 4 goes into 180 how many times?
45.
25 times, right?
45.
45 times. So 5 times 45 degrees. Notice that kind of gives us an answer. That's how you can check. Anyone know what that is?
245.
225. Before we continue, everyone okay? So these are obviously nice answers. Right? Any questions on what I'm trying to show you? Honestly, radians is a unit that we tend to use a lot in advanced functions and in physics. So that's why early exposure right now will make it easier. Let's just say you didn't have a nice question like this. Oops, I'll rewrite that. We'll just do one. And then I'm going to show you something neat, and that'll hopefully end our main lesson. So our next one is convert 2.68 radians, 2 degrees. How are you going to do this? Well, same thing. But this time I need to calculate, right? I actually don't know this answer. First of all, the radians divide by the radians. And all you do is take your calculator, 2.68 times 180 degrees divided by pi. Use the pi button. And this answer is approximately 153.5 degrees. Okay. And I truncated. I should have written it. Maybe around 2. Okay. Flora.
But then how about the pi? It doesn't cancel out.
Notice the pi, there's no exact number here. Unlike these examples here, the pi's actually divide out. So these are actually expressed in exact form. Exact form. This is like an approximate answer, 2.68. And this, notice this angle is not a nice answer anyways.
But for the pi, do you divide it by 2.14 instead? Or do you just...
No, I'm not using 3.14, I'm using pi. I'm not using 3.14.
So you're in
how did the
radians?
calculation go?
I use pi, so
Are you in radians on calculator?
no, not yet. Hold on.
But then
Okay,
where did,
Flora, ask your question again?
yeah, where did the pi go then? Cause
It didn't go. 2.68 times 180 degrees divided by pi.
And is pi just put on floor?
There's a pi button on your calculator.
You put it like on.
So the actual, so 2.68 times 180 degrees divided by pi. Is that okay? So is that,
so pi in radian has another value, like it's
No.
has active value.
see, so you're not following. So in this example here, 5/4 pi's, not 5 quarters, 5/4 pi, the pi's actually divide out. In this case, it didn't. That's why you guys have trouble understanding the definition of exact versus approximate. But it's okay. It's okay. This is what you're learning. So this is what I'm trying to show you. This is 2.6, not 2.6. If this was, let's change the question. If it was 2.68 pi radians, this is totally different, right? That's like a coefficient, and that's like a variable, right? So in this case, 2.68 pi times 180 degrees of pi radians, then you're just going to do 2.68 times 180, which is a different answer than this. You see what I'm saying? So that's why I was trying to show you the 1 degree and the 1 radian. It's actually not a very useful unit conversion. No one memorizes this. Rather, most students memorize 180 degrees equal pi radians, or pi radians equals 180 degrees. Okay? Let's just erase this because I don't want to confuse any students. Up top. Maria, did you have another question?
Yeah, I had a question when you convert degrees to radians, is that when you use radians on a calculator?
I'll show you in a moment.
Okay.
Okay? So any other question about radians before I show you something really neat? Any questions at all? I think so. So to finish off our radiant lesson before we combine it with cast and everything, just to show you something here, I'm going to draw two kind of semicircles. The first one, I'll show you the degrees, but I'm only going to go to 0 to 180 because it's just a little easier. And watch what I'm doing. I'm not going to draw the arrows, but a lot of you can see that I divided this from 0 to 180 into 6. You see that? Into 6s? So a lot of you already know all these measures are, that's 30 degrees, and I apologize, I'm not going to do it all. Is that okay? Because it's going to get messy for me. That's 60 degrees, and that's 90. So far so good? So I think a lot of you can do it. That's 120, that's 150, and that's 180. Is everyone okay? Any questions? I apologize, the 120 is a little weird because it's the relative acute angle is not 30. But a lot of you see I'm doing every 30 degrees, right? Everyone see that? Any questions? Everyone okay? So if we travel, a lot of you know what I'm trying to do. That's 0 radians, and that's pi. Right? So I divide this into 6, right? So 30 degrees. Well, can anyone do that? What's a 6 of pi?
Pi over 6.
Sorry?
Pi over 6.
Pi over 6? Is it okay if I don't write the radians?
Yeah.
Yes, because it's going to be there. So pi over 6 radians. This one is 2 pi over 6. But we reduce that fraction. Can anyone actually reduce that fraction?
1/3.
Pi over 3, 1/3. Nicely done. And this one, a lot of you can do it. That's 3 pi over 6. What will we reduce that to?
Pi over 2.
5 over 2. Keep on going. This is 4 pi over 6. More.
2/3.
Thank you. 2/3 pi. And the last one is 5 pi over 6, which I think a lot of you already know that was our first warm-up question. Not warm-up question. First question related to convert degrees, 150 degrees to radians. 5 pi over 6. This is why fractions are actually being taught, so that you can do this with relative ease. That's why some of you would think on your test you're asking me, Mr. Chen, I can't give you the exact answer in a fraction because no one memorizes those weird angles, right? This is the whole essence of the special triangles, right? So in a nutshell, for our special triangle for this one, oops, I should have done that in white. That is 30 degrees, and that's 60 degrees. And I think that's 1, 2, and 3. But a lot of you are now understanding now, if you change 30 degrees to pi over 6, and we change 60 degrees to pi over 3, it's the same thing. You can still use cast and the special triangle, which eventually we're going to hopefully answer Maria's question. Notice I try to show you. I don't want to get it so messy. Let's do it again. A lot of you already know, instead of breaking it into 6s, and again, I only do semicircles, is that okay? Can someone try to read Mr. Chen's mind? What's this angle? If I bisect this angle 90 degrees, exactly how?
60?
It's not 60, which is the triangle. Bisect. Flora?
45.
45 degrees is correct. And I'm not going to give you that one, is that okay? But a lot of you can tell this one is 135. Okay? I'm not going to do that, is that okay? So same idea. Again, I'm only doing half of it, so okay, because a lot of you understand it's the same thing if you keep on rotating. So that's 0 radians. That's pi radians. That's also pi 2. Anyone help us out? Just like that. Grace?
Pi over 4.
Pi over 4, because half of a half is a quarter. So can anyone do 135? No pressure? Just like that? What's that answer? Grace again.
3 pi over 4.
Yeah, 3/4. Because this one is really 2 pi over 4, and this one's really 4 pi over 4. Okay, what's what I'm trying to show you? So some students find this a little easier. When you see this, actually, it's used a lot in senior level math textbooks. They tend to show this more. And again, to illustrate it again for our isosceles right triangle. Again, that's 45 and that's 45. That's just really 4. And so we use quarters and sixes to solve things. And this is actually what a lot of you realize, and I'm not going to show the people at home. The clock, you see it, from 12 to 6, each segment is a sixth, right? For a total of 12. This is actually the reason why degrees are used, because of sixes, right? So, any questions about what I just showed you before we now get to Maria's question? Flora.
I just have for the same question, but like.
This one again?
Yeah, but why isn't pi equals to 180 when divided it, right?
Sorry? Okay, because 360 is by definition the answer.
Yeah.
But divide both sides by 2. Let me get that answer. So pi radians is 180.
But why isn't it like divide by 180 then? It
Sorry?
should be equals to 1.68 then for the result, isn't it?
Sorry, what?
Cause like you said pi radian equals to 180 degrees.
That's
then
correct.
You're supposed that equals to be 2.68 times 180 divided by 180.
That's why I'm trying to show you, like, in this diagram here, like if I ask you what's 1 radian? 1 radian? Not pi radian, 1 radian. 1 radian, this is actually hard for me. 1 radian, well that's 3.14, so that's 1.51, whatever. So 1 radian is maybe like this. It's slightly more than 30, but less than 45. It's like a weird measure. I think it's, no, it's maybe slightly more. See, even I can't do it. I can't even do it. I find that going with decimal radians and decimal, like that's like 1 degree, like a lot of you know 1 degree is even in math, but like, to tell you how far that is in terms of radians, it's not a nice number. So that's why we don't like using the actual definition of what a radian is or what a degree is with themselves. This is easier because you can see it from the picture. Like I've gone half the circumference, and that's 180. Like you can visually, what a protractor looks like. That marking is pi radian. That's actually the distance traveled, which is related to the angle. Okay. Look at the notes in the arc. It also does it a different way called arc sectors. That might, I think, is a little more confusing. I actually think this is easier.
Yeah, I understand this part. I just don't understand why you divide by pi, which the value is 3.14 instead of.
It's not 3.14. See,
There's like 3.1 for like something else.
Yeah.
You have to convert it. If you're just doing 180 over 180, then you could answer the question.
Yeah, if you do 180 over 180.
Working in radians.
Like, why don't you just make a 180 over 180?
Yeah, that's like this definition. 60 seconds is equal to 1 minute, right? 60 and 1 are not related, but they're units. This is why it's called unit analysis. This is why you look at units. That's why I am stressing radians for us in grade 11, so it's a little easier. Okay, so maybe I'll answer Flora's question. So let's get to the extension question that Maria was asking, and then we'll pause for this moment. So watch carefully, like your test. Here we go, really easy. Solve for theta. The theta is in between that. And we'll make it easy. Sine theta is equal to negative 0.8. So the question is not that hard, because we have a negative ratio, and we have some cast rules and stuff like that. The only tricky thing is the domain. Everyone agree? That domain is not from 0 to 360, but it is 0 to 2 pi. So it's positive still, so we're going counterclockwise. Yay! So this is now where you take out your calculator, ladies and gentlemen, and you change your setting into degrees. Now don't get into radians. Now don't get me wrong, technically, you can still do this question and work in degrees, and then use the conversion backwards to go back. But most of us just want to do it once, and I'm trying to teach you how to use it, your calculator. So I'm not saying you can't work in degrees and then convert. I like working in radians. So the way that I would solve this, watch carefully. I know that this is a negative ratio, negative 0.4, and it's for sine. So the angles that are going to form are in quadrants 3 and 4. So that's going to be your first answer, and that's going to be your second answer. Before we continue, everyone okay? Okay. But since I'm working in radians, I do the inverse sine of negative 0.4. And make sure your calculator is set in radians.
How do you do that?
And how do you do that? There's a button called DRG. D stands for degrees, R stands for radians, and G stands for gradient, which I'm not going to explain unless you really want me to.
Why do you have to put it in there?
Because this question is the domain is between 0 to 2 pi. One more time. I would like you to try to learn how to use radians, but you can definitely do this in degrees if you want, and then do the conversion afterwards. But I'm only going to show you one way today. Is that okay? So in radians, I got negative 0.5, and inverse sine of negative 0.4. Hopefully everyone's playing along with Mr. Chen. And what did I get? I got negative 0.4115. Keep on going. And this is weird for some of you, right? But remember, this is an angle. That's what I'm trying to show you, the whole big idea. You're not used to it because this is a decimal, right? Well, what does that mean in orange chalk? I don't have green. Well, I do have green, but it's not going to show me. This answer is actually this. Everyone see that? The negative tells us it's going clockwise. Everyone see that? So you have to be thinking in radians. Not degrees, but in radians. But a lot of you can tell me the related acute angle. What is it? Yeah?
0.41.
That is correct. So, to find the first angle, normally you would do 180 degrees plus that related acute angle. But we're not working in degrees anymore. Can someone help me out? Instead of 180, what would I use? Grace?
Pi.
Yeah. Pi plus that related acute angle. In this case, pi plus that 0.4115. So let's just do that really quickly. Pi plus 0.4115. And that's approximately 3.55 radians. Let's do 2 decimals so that everyone gets the right answer. I'll just move this over so people can see it. In the second angle, again, normally, we would go all the way to 360. We would use subtract 360. But I'm not going to use 360, because that's degrees. What would I use? Any volunteer? Plural. 2 pi minus that related acute angle. So in this case, 2 pi minus that 0.4115. Again, notice the concepts are still the same. Related acute angle, when Sava gave us this answer, there's no direction, right? But the calculator gave us this answer, so we have to interpret what the calculator is telling us. So that's why, so you just do 2 pi minus that 0.4115. And notice that this is a weird answer, right? 5.87 radians. But those are the two answers. How can I check my answer? Make sure you're in radians and take the sine of 5.87. I'm gonna just show Alex so you can see this. Sine of 5.87, and I press equals negative 0.401, which is kind of close to our answer, right? So you can always check your answer, right? Even though the calculator did not give us these answers, it gave us into radians. One more time. You can definitely do this question using degrees. Then you just get a negative degree angle, and then you get degrees and degrees, but then you have to convert them because the domain is not in degrees, but it's in radians. Grace, really quickly.
Is there a way to get the answer?
Yes, but I don't want to show you.
Like in terms of pi.
I'm not going to show you. Oh, in terms of pi? Not
Yeah,
calculator.
like I know there's this. I have this other calculator.
I know you have this other calculator. Yeah. It's called the Cassian.
Huh?
Huh? Cassian or Texas
Oh
Instruments.
yeah, yeah. I have
Yeah. There are other calculators that are better than those. That's why we don't like using this calculator for exact answers. We want to use this to get exact answers. Saba!
What's grad?
Okay, so we'll talk about that in a moment.
I